Hey everyone, today we're going to be looking at infrared spectroscopy graphs. Okay, now this tells us a lot of information about our molecule in regards of functional groups. So you can see over here functional groups, functional groups, functional groups. Now this will tell us our major functional groups that we have in our molecule and also help us decipher what molecule it is and which peak is what functional group. So infrared spectroscopy graphs, along with other graphs, can be a very good indicator of what molecule we have, but even by itself, it can let us know what functional groups we have. So let's go through a couple examples and see what molecules we can have depicted by their functional groups. Basically how to read it. So this table on the right hand side is a table of the most common bond types and their frequencies. Okay, so remember in infrared spectroscopy graphs, on our y-axis we have transmittance, so percent transmittance, and on our x-axis we have wave numbers. Okay, so it's basically how many waves fit in 1 centimeter, and the graph goes down. Basically, the only thing you have to remember is that at certain peaks, right, our wave numbers change as they go along the x-axis, and depending on the shape of our peaks and where they are, like what their wave number is, we can tell basically what functional group it is. And this is from our trusty table over here. So let's go through this example. So if I asked you about this peak over here, what would you say it is? So this peak over here basically describes this whole thing, this whole broad thing is right around 3,400, right? 3,391. So is that anywhere on our table? Actually, yes, it is right here. So this is likely an OH group part of just an alcohol. Now, this is actually pretty characteristic. So anytime you see a fat curve over here, right around 3,000, 3,500, there's probably an alcohol somewhere in your group. Now this tells you that our molecule is either an alcohol or it has a carbonyl group somewhere in there, which may be a carboxylic acid or anything other than that, okay? But right now what we know is that we have an OH group because we have a wave number right around 3,400. So we can write that in. So we have an OH. Okay. What else do we have? Well, let's look at this one. So this one's right around 2,900, 3,000. So this one right here. So this describes this little peak over here. So what is this one? Well, usually around 2,900 we have a CH bond, which is actually this guy up here. And you can kind of see its frequency number is right around 2,900 as well, which is very good. So usually in most IR spectrum graphs, you're going to see a peak right around 2,900, and it's usually a CH part of an alkane. If it's a little bit more, it'll probably be an alkene, but for this guy, it's going to be an alkane. Do we see anything else? Well, we are likely to have something else. Let's label these two peaks right here. So they're pretty close together, right around 1,000, 1,100. What do these peaks tell us? Well, actually, these ones aren't really on our table, so we'll ignore them for now, but they're most likely a C double bonded to a C. Okay, I don't think it's on our table right now, but usually this depicts a C double bond or single bonded to another C. Okay, so we know from this graph that we have CH, we have an alcohol, and we probably have a C single bond to a C. So in conjunction with other graphs, we can kind of tell what formula or what molecule we have, but just knowing what basic functional groups we have is quite useful. And let's actually see what this molecule was. So I'm going to keep that. So this one was OH. This one was C, single bonded to a C, like we said. Very nice. And then this one, it's actually a C double bonded to an O. Which actually makes sense because we have an alcohol. Oh, yeah, it's actually right here. Sorry, this is my bad, I missed it. So it actually was on our thing the whole time. It's actually down here. I don't know why it goes 1300 to 1000, but between 1000 and 1300, we usually have C single bonded to an O for alcohols, esters, and ethers, and this would make sense. So that was actually my mistake. So we do have a C single bonded to an O instead. Okay, so we know our molecule has C single bonded to an O, a CH, and an OH bond. And this actually is for ethanol. And this makes sense, right? We have our OH right here. We have our CH, 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 CH. And we actually have our C single bonded to an O. So this one makes sense. Nice. Let's try one more example. So, given this IR spectrum, can you tell what these functional groups are? Well, there's always a couple patterns that we can see. Well, we can see pretty noticeably, we have this fat curve over here. And it's right around 3000, a little bit higher. And just like our last one, we have another alcohol. And see, it's pretty broad. Okay, so this one's pretty broad, pretty fat. So we have pretty fat curves. This means that it's probably an alcohol, and a lot of molecules have alcohols, so it's pretty common. So this one is going to be our alcohol. Nice. What else do we have? Well, remember what we said? At 2900, we always usually have a CH bond for an alkane. And right around 2900, you can kind of see this little peak over here. So we probably know we have, this one didn't ask for it, but we know we probably have a CH bond somewhere over here. Okay? Let's draw a better arrow. There we go. Nice. And it's also asking for this one. So this one's right around 15, 16, 17, around 1720, 1740. Well, what could this one be? Well, see, we have a couple options over here. So you can kind of see these ones add up to, we have all these carbonyls. And depending on what else they're attached to, if it's a carbonyl and a ketone, carbonyl and aldehyde, carbonyl that's part of an ester, carbonyl that's part of a carboxylic acid, carbonyl that's part of an amide. Although they're all quite close, they're all slightly different. So just from this, we probably wouldn't know which one's which, because reading this, it could be 1720, but it could also be 1740, even 1750. But we know that there's an OH group also. So we know that it's probably a carbonyl that's part of our carboxylic acid, okay? Because that's the only way you can have a carbonyl and then an OH as well, is with carboxylic acids. So we know that it is probably this one over here. Carbonyl that's part of carboxylic acid, okay? So we know this guy is probably carbonyl. That's probably part of the, let's try that a little better, carboxylic acid. So we know that whatever our molecule is over here, we know that we have carbonyl, probably an OH somewhere as well, and then we have CHs all throughout. Okay, so this kind of tells us what functional groups we have. So infrared spectrum graphs are really useful for finding out what functional groups we have based on these kind of broad or sharp peaks and what their numbers are, but they're usually best with other graphs that tell us, I know what functional groups we have, but what else could I use to help me figure out what the whole molecule is? But infrared spectrometry graphs are very useful for functional groups. Okay, thanks.